More multiplying. This is the hardest version. Easy, medium, and difficult problem here. Before we go into that though, this is the biggest thing I want to lead you through to make sure you're clear on this, so that when you're clear on this, a lot of this stuff will make sense. What is x plus y equal?
XY.
What?
XY.
That's interesting. I'm going to ask you another different question.
No, it's
what is
just
x times y?
XY.
xy.
So x plus y is just...
Because anytime in math you have two things sitting next to each other, like this. Like if I had 2x, what operation is that is happening here? Multiplication, 2 times x, right? Or if I have 5xy, that's 5 times x times y, that's multiplication. Okay, so you can't say x plus y is xy, because now I've just changed addition to multiplication out of nowhere, right?
Yeah.
So what would x plus y be?
X plus y.
Interesting. So now, like sign changing and stuff like that. The answer that's very underwhelming, and it's actually what I led this whole unit with in the first video, is x plus y.
That's what I just said.
Yep, you got it. So that you can't do it. I don't know what x is. I don't know what y is. So I definitely don't know what they are added together, right? Nor can I change signs or change multiplication operations and stuff. It's just that. Okay. You could also say like not simplified, like. You can't simplify it or whatever, okay? Because it is that, right? Or you just write the same thing again. Now, here's my next question. What's x plus y plus, or sorry, what's xy plus xy?
2xy.
X, y, y? Interesting. It is 2xy.
Yeah.
Because I have 2 xy's, right? Right, cool. If I had x, y, y, something like that, that's now multiplication, and I lost my, I'm just now multiplying them all together. So the biggest thing is if you did say an answer, you can almost check your answer if it makes sense, if the operations all make sense. Because I have one of these things and another one, I have 2 of them done, okay? Now, this is a little different. I'm trying to push the edges of the weird spots to try and make you confused. That's my goal here, is to make everybody confused and then pull you out of the hole that I put you in. xy plus yx.
This xy2.
Squared. Oh, so squaring things comes from multiplying and adding. So I'm not multiplying anything, so I wouldn't be able to get any exponents here. So that's interesting.
2xy.
Is it still just 2xy?
It is 2xy. Yes.
Why?
Now, I could also say, you could write, I'm going to put or right here, or 2yx. Sure, right? Because here's my question. Is xy any different than yx?
No.
Okay. Why? If I have 2 and 5, 2 times 5 is?
10.
5 times 2 is?
10.
Doesn't matter, right? You can mix it all up, it doesn't matter. So really here, this is saying 2 times x times y. This is saying 2 times y times x. It doesn't matter, okay? I can say them however I want. So when I look at these two things right here, x, y, and yx are the same thing. It's just me reorganizing them differently. In fact, if I have 2x plus 2x, that is 4x. But if for some weird reason I'm trying to be a jerk like I am, and I said 2x plus x2,
It's the same thing.
that is still 4x. I just said the variable x and 2, you'll never see this. This is very unprofessional, okay? But I'm trying to shake things up here, okay?
Does it still work with multiplication?
Work with multiplication, what do you mean? Give me a problem.
Oh, no, like if I just switch like the variables like around, it still works if I was
Yeah,
multiplying.
as long as I switch, like if I have x3 and I switch that around, I can switch these around. Like I could say y5x. It doesn't matter, okay? That's very weird. Normally you have the number and then in descending alphabetical order from there is usually the structure I try and do for consistency. But that's the biggest thing I want you to see here. And then the final point here, and then we'll fly through the rest of these. X squared y plus yx squared.
You can't.
My first question would be, can I add them together? That should be a thought process you have of, can I even do it in the first place? Because you should be super paranoid from all the stuff I've been doing. So can you add these together? Okay.
Yes.
No.
I think yes.
So you see how I'm purposely trying to combine multiple rules here to try and challenge you and shake you up here? For my x's, to see if I can combine like terms, I have to have x squareds compared with x squareds, right? So do I have the same amount of x's?
Yes.
Do I have the same amount of y's?
Yes.
Yeah. Does the order matter between the shuffling?
No.
No, so that, yes, I would say this is 2x squared y. I can do those together, that's fine. Now,
Is it 2y?
2y? No, this is just a variable. I have this many of that and this many of that, so I have 2 of those, right?
Oh, okay.
If I was multiplying them together, right? If I was multiplying them together, then I would have 1 times 1 is 1, because I have a 1 in front of here, if you want to think of it like that. X squared times x squared is x to the 4th. Y times y is y squared. That's maybe what you're
So when
thinking
you
about.
put 2 in front of xy, that's 2x and 2y?
I have 2 of both of those.
Okay.
I have 2 of the following that it comes behind it, right? All right. My last little riddle here is x squared y plus y squared x. Can I add those together?
No.
No, I cannot add those together because look at my x's. Do I have the same amount of x's?
No.
Are those like terms? No, I don't have the same amount of y's. It's not like terms. I understand that there are x's and there are y's, but an x and an x squared are not the same thing. Whatever x squared is much larger than whatever just x is, okay? So there's all of that. Okay, so now, number 10. We're gonna start actually going through here, right there. And yeah, cool, all right. Number 10, I am gonna take this times that. So I have 8 times 1 is just 8. X times x is x squared. Y, there is no more y's, he just tags along.
Nice.
Cool, super simple. Next one, this guy times that guy. 8 times 8 is 64. X, there is no x's. Y, hey, here's another y. So it's just y squared. When I multiply numbers, I add the exponents. Okay, cool. Now, combine like terms. Here we go. So I got all these now. Can I combine these?
No.
No, because I have x squared and x. Those aren't alike, and these aren't alike. That's why I did all that blabbing a second ago. Okay, that's your answer, right? If this was x squared y and this was x squared y, sure, add them together, but it's not. Okay, because once I find out what x is and plugged it in, let's just pick a number for x. What is it? 3. Let's just say for now. I don't know. I don't know. I'm just making something up right now. If x was 3, that's times 3. Is this times 3?
No.
No, it's 3 squared, which is 9, which is not the same. See? So anyway, no matter what the number x was. All right. Done. Number 10, there's your answer. Number 20, medium difficulty now. I have x times 5x is 5x squared. I'm just adding on an x right there. And I'm doing the same thing here. So plus 7xy. If you wanted to write yx, sure, you could do that, but then I would always make sure you write the y's first so you don't get confused with this versus that situation, okay? Mm-hmm. Whose turn is it now?
The 6y.
6y's turn. 6y times 5x. I have 6 times 5 is 30. Y and x are just going to glue them together so I have xy. Or again, yx. And lastly, I have he pairs up with both of them. 6 times 7 is 42. 42. Y times y is y squared. Because 1 plus 1, I'm adding my exponents, okay? And I'm done.
No.
Oh, good catch. What do I have to do?
You have to combine your like.
Combine like terms. X squared, I'm looking for any x squareds. I got none of them, so I have 5x squared. Done with him. XYs, I do have another group of XYs, so I add them up together for 30 plus 7 for 37 XYs total. And then I don't have any other y squared, so I just have plus 42y squared. Done. Okay.
23.
The last one. Okay. I want to show a different way here, and this would be the big, huge. If you want to try and take away something from this, this would be it right here. I want to think about something different. I'm going to let you into my head. Here's how I think of it whenever I see this thing and whenever I do this, okay? If this helps, cool. If not, just keep on doing the thing that you know how to do. I'm just trying to show another way. So I have a 3x and I have I have a 3x and I have a what?
Negative
Minus.
one.
Very good. I have a minus y. I have a negative y. That's very good to catch that. That's why I wanted to, because that was a test. All right. So whenever I do this, I'm going to, it's like a game plan where I'm about to do this problem, but let's talk about it in an annoying way that you guys are like, shut up and do math, okay?
Yeah.
Dance, math puppet. So I'm going to take this 3x and I'm going to do what with it?
You're gonna distribute.
I'm going to distribute it to all 3 of those people. in very basic non-math terms, what am I basically doing to all three of these people? I'm basically going to do what with them?
You're just multiplying by
I'm multiplying all the numbers
by 3.
times 3. So all of these numbers are going to be 3 times bigger than what they are right now. And
They have an x.
what am I going to do with that x?
Adding it to
I'm just going to glue it on and tack it on there to each one of them, right? Like a little plus x plus x plus x. So this is going to be up by an x. That's going to go up by an x. And then, I'm just going to glue them on there. That's the big picture, right? And if you think of it like that, sometimes it gets a lot easier. So now this guy's going to be multiplied by 3. So 6 times 3 is 18. I have x squared. I'm adding one more. Cool. Next one. Do it again. 3 times 5 is 15. I glue on another x there, so there's 2 of them. And then the y keeps staying the same. And then 3 times 7. Almost messed up.
It's a negative.
3 times negative 7 is negative 21. And I'm just going to keep my x's in order, and then I have the y squared, right? So 3 times negative 7 is negative 21, x, y squared. Cool. So the 3x is done. Now it's this guy's turn. What am I doing, or what am I thinking about whenever I'm doing this? What's going to happen to each of these 3 things?
Divide them.
I'm what?
Divide them.
I'm not going to divide them.
You're just going to multiply them by negative 1.
Multiply them by what?
Negative 1.
Negative 1. I'm multiplying them by negative 1, yes. So each one of what's going to happen to each one of these numbers now? Instead of being multiplied by 3, what's happening to each one of these numbers? What's going to happen to all of them?
They'll become negatives.
They're going to what? They're going to become negatives? I would disagree. If I take a negative and I multiply it to all of these, they are not all going to become negative. What? Oh, I didn't know if you heard it or not. If you were to explain to a 5th grader, and I try and have you think of it like this because I want you to make it as simple as possible and not be too complicated. If you were to explain to a 5th grader what happens when you multiply any number times a negative, what happens to any number if you multiply it by a negative?
The sign switches.
The sign changes. That's huge. It doesn't become negative, right? Because that's going to be a negative 6. That's going to be a negative 5. But what happens here?
Oh, it goes to the positive stuff.
That's a pot. So I don't want you to think like, it just becomes negative. I disagree because of this. It changes the sign. That's very well said. Okay, cool. So I'm going to change the sign and then glue on a y to each of these people. So I have here, negative 6 is the whole negative situation because it's opposite from what it was. And then I have x squared y. Or yx squared, whatever order suits you. Negative y times this is going to be negative 5 because the sign changed. I'm gluing on an extra y right there, so I have xy squared. And this guy is the final one. Negative times negative 7 is going to be a positive 7 because that negative changed it. And then I have y cubed. I ran out of room at the perfect time. Can you still see that? Yes, you can. So cool. Now what?
Now you find the like term.
Combine like terms, yep. So I got this guy is going to be just regular old 18 x cubed. Cool. I need x squared y's. I need x squared y's.
The negative.
No? Yes, this guy's what I'm looking for. So I have 15 minus 6 is going to be a positive still because there's more positives than negatives, and that's 9. Okay? X squared y. Now I'm going through here. This guy's done. This guy's done. This guy's done. I have this thing here. I got xy squared, xy squared. These go together. So negative 21 minus 5. Your bank account balance in your debit card is at negative $21. You're in debt. And now I go out, spend $5 more and lose 5 more. So I'm at... Uh-oh. I don't know. I just have money and I just swipe the card and stuff happens. I don't know. Negative 21 minus 5 is even more negative 26. Last class was like, negative and negative, make a positive. That's not how, if I'm subtracting and I just keep subtracting, it doesn't just magically become positive, right? Especially not with your bank account. And then we have xy squared. Cool. And your final plus 7y cubed all by himself. Okay, and that is your answer. Combine like terms, be careful, organize your variables, and eat your vegetables.